Okay, let's go ahead and take a look at Lesson 12, Bubble 7C together. It's the number tilting game. It says the app simulates a game where you try to match a number with a randomly generated target number. You can tilt the microbit left and right to adjust your number, trying to get it as close to the target as possible. Once it's close enough, press the B button on the microbit to lock in your number. The game has already been started, but the code that updates your number based on the microbit is missing. We'll need to use variables and the counter pattern to update our number and update the screen. So as you can see, they've already done a lot of work here. So they've created variables, they've set the text that's up in the boxes, they've already coded the B button being pressed on the microbit. So they've already done a lot of it. All we have to do is figure out how to make this number actually change, really. So let's make sure we understand what's going on here first. When you tilt the microbit, either turning it to the left or to the right, all right, we're going to get a number that's going to show up on the screen. And then there's going to be another number that's randomly generated there that pops up in that box that says target. Your goal is to get as close to the target as you can, and once you think you're there, you're going to hit the B button, and that's going to lock in your response. Now, once you hit that button, it's actually going to say on the screen how close we were. All right, so can't really run it yet because we haven't done any of the code to make the tilting work. So let's put in that code. All right, so the directions are right here. It says to detect when the microbit tilts left or right and store it in a variable. Okay, well, the good thing is they already made the variable up top here, and it's called your number. So I don't really need to define the variable. I just need to call it back up. So I'll just grab an x equals, and I'm going to say your number is equal to the accelerometer's orientation for its roll. So that's going to get whatever number I get when I tilt it left or right and store it in your number. Now, just because I'm storing it in your number doesn't mean it's going to show up on the screen. That's also up for me to do, which is what we have right here. Okay? All right. Well, in order to do that now, I have to set the text. And what am I setting the text of? Well, as we can see when we use our hover trick, we can see it's called your number label. And we want it to display this variable because remember, this variable holds the information already. So I'm going to take all that out and just type in your number without the quotation marks. Remember, when I'm recalling a variable, no quotation marks. And I'm going to give you one other little thing that they don't mention here. I'm going to give you a set property block because the text comes up a little bit funny here. So we're going to say for your number label, we want the font size to be 14. Okay, and let's try it and see if it works like I described. So I run my code, and as I tip it left or right, as you can see where it says your number is changing based on wherever I'm tipping it. Again, left or right, not forward or back. All right, so once I've gotten as close as I can to my target number, 62 in my case. Now realize yours will be different because it's a random number generator. But once you think you've gotten as close as you can, hit that B button. All right, and as you can see, once you hit that B button, it's going to tell you how close you were. So it's going to say your number, in my case, was 1.5 off from the target number. All right, I'll run it again and I'll go way the opposite direction just so we can see that it's going to tell me how far off I really am. So it's positive 59, but I'm going to go into the negatives and hit the button. And as you can see, I'm 128 units away because I'm 59 positive plus all the negative distance away, which gives me that 128 that I see on the screen. Okay, so that takes care of that one. So we're going to move on. So as noted here in the directions today, we're going to use a different bubble for the assessment. I'm not particularly fond of some of the other stuff. Some of the other stuff was designed for Circuit Playground and they've tried to adapt it, but I don't think it's been done very well. So the assessment bubble today is going to be 9B, and I'm going to help you with the first part here because we've never done this, or at least one thing in here. So let's take a look. All right. It says many construction tools or equipment have safety sensors built into the devices so they can only be operated under certain conditions. This helps avoid situations where someone injures themselves by accidentally using the device without taking the proper safety precautions. Create an app that simulates firing a laser by pressing a button, but will only work when the device is pointed away from the user, so the laser doesn't go into their eyes. This requires using the accelerometer and detecting the roll or pitch of the device. They're kind of leaving that up to you to figure out which one. The app has been started for you so that the screen will display the roll and pitch of the microbit. Your task is to determine the roll or pitch when the microbit is facing away from you. Then add code so the LED screen only turns on when the microbit is in the correct position. Okay, so I'm holding my microbit in the correct way so the cord is up to the top. All right, I can have my fingers on the A and the B button. The A should be on the left, the B should be on the right. All right, and I'm pretending that where that cord is coming out is a laser. And I want to make sure that no matter what I do, that that laser is always facing away from me before I press the button to trigger the firing of the laser. And when I do this correctly, everything on the microbit is going to light up. So every little pin there on the microbit should light up. Okay, so the first question is, does the roll actually matter here? Well, think about it. Does left or right actually matter as far as going away from me? No, not really. All right, it doesn't matter if it's left or right. I can have where that cord is coming out facing away from me no matter what when I go left or right. So that's not an issue. So the real issue here is the pitch. Okay, I want to make sure it's not too far up, because if the pitch is up, I'm going to fire that laser right into my eye. And if the pitch is down, I'm going to fire it right into my big toe. All right, so that's the thing I want to be careful of. Okay, so we have to write a statement that says that. Now, we've never actually written a statement that can do that. If I said you write two separate statements that could do that, we'd be okay. But to write it in one, that's a little more challenging. So let me show you a new piece of code. We're going to start with an if block from control. And I'm going to write two variable statements in one here. So I'm going to say if the pitch is less than 10, and then I'm going to say double ampersand, that's two and symbols put together, and I'm going to say if the pitch is greater than negative 10. And as you can see, that combines two greater than or less than statements into one block of code, and that's the piece we've never done before. So what does that code do? That ensures that the microbit is relatively flat. Okay, if I go too far down or too far up, that's going to violate the conditions. All right, and again, I don't want to fire the laser if I'm too far up or too far down, because again, I'll take out my eye or my big toe. All right, so once I make sure that that condition is met, all right, which I've just written for you, there's only two pieces left here. Okay, the first piece is to turn on all the pins on the microbit. So there's two ways to do that. There's an easy way and a hard way, which you know both of these already. So from the microbit, you can either LED screen on every pin, or you can use the display code. Remember, one is on, and that'll go inside the if statement. And then the only other thing you need to add is an onboard event to check whether the A button is pressed. So you already know how to add an A button press code. Again, it's an onboard event. All right, and then all you have to do is embed this inside the onboard event. Again, this will serve as your assessment bubble. Lesson bubble 8 will not be used as assessment, even though it is marked as such. So please make sure you complete this bubble. Again, you do want to copy down that piece that I've already written for you and finish it according to the directions I just gave you.